Okay, so today we'll start 3D geometry part 1. Before starting, we have to see some basic concept of three-dimensional geometry. So as you have seen in class 11th also, this is coordinate axis x x o x dash. Can you see x o x dash and y o y dash and z o z dash? Okay, so if you see this, suppose I'll take A, suppose this is A. So X, A, here some point we can take it, and this part, this is called X, Y plane, bottom one. Are you understanding? This is X, Y plane, okay? And the back wall, you can say the back wall, this is Y, Z plane, and this left side wall, this is called Z X plane, and X O X dash, Y O Y dash, Z O Z dash are mutually perpendicular lines. They are called X, Y, and Z axis, and O is the origin. So, and these three lines are also called as rectangular coordinate axis. Rectangular coordinate axis, and this is XY plane, this is YZ plane. And coordinates of a point, if you want to, suppose this is A, B, C, D, E, F. So what will be the coordinates? This is P point. Here it is point P. This is point P. Can you see this one? So x-axis, when you drop the perpendicular on x-axis, this distance is x. This distance is x. On y-axis, distance is y. On z-axis, distance is z. So the coordinates of the point P will be x, y, and z. Okay. Now we will write the coordinates of point A. What will be the coordinates of point A? A is on xy plane. So when the point lies on xy plane, its z coordinate will be 0. So x, we can see this is having x distance, it is at an x distance and y distance. So from x distance from y axis and y distance from x axis. So its coordinates will be x, y, and on xy plane, z coordinate will be 0. Okay. Similarly, if you go to this plane, YZ plane. So on YZ plane, x coordinate will be 0. So 0, YZ. Coordinate will be 0, YZ. Similarly, E is on XZ plane. When it is on XZ plane, so Y coordinate will be 0. So X, 0, Z. Now, these are the points which lies on XY plane, YZ plane, and ZX plane. So point on X, Y plane is equal to A, whose coordinates are X, Y, and 0. Similarly, the point on YZ plane That is C here, 0, y and z, and the point on zx plane is E here. So its coordinates are x, 0 and z. Okay. Now the question rises, what will be the coordinates of the point on the axis if the point lies like B? B lies on y-axis. When the point lies on y-axis, then x and z coordinate will be 0. Okay. Similarly here D lies on z-axis. So if it lies on z-axis, so x and y coordinate, x and y coordinate will be 0. Similarly, this is f and the coordinates of f lies on x-axis, so it will have only x coordinate and y and z will be 0. Correct. So these are the coordinates of a point in a space. And now some important formulas that maybe we studied before also, but we have to see some formulas here again. Distance between 2 points. First, we will see distance between 2 points. Distance between 2 points. It's same as in 2D. If A is a point whose coordinates are x1, y1, z1, and the coordinates of B point, there is a B point in the space whose coordinates are x2, y2, and z2. So find the distance between AB. So it is the same formula, AB is equal to, you know that, under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Second section formula is also same, only one coordinate axis is increased, one coordinate is increased in the section formula. So section formula also, you know that there are two section formulas, internal and external. So section formula for internal division, suppose this is the line AB, which is divided by point M in the ratio M1, M2. And the coordinates of A is x1, y1, z1. And coordinates of V are x2, y2, z2. Then what will be the coordinates of M? Let us take x, y, and z. So therefore, it is dividing internally in the ratio of M1 is to M2. So x coordinate will be equal to M1 x2 plus M2 x1. Then the point is dividing internally upon M1 plus M2. and y coordinate will be equal to m1 y2 plus m2 y1 upon m1 plus m2, and the z coordinate will be equal to m1 z2 plus m2 z1 upon m1 plus m2. And you know that if this point is outside the line and it is dividing externally, suppose if the point is outside the line and it is dividing in the ratio m1 into m2, that means this is AB and point is outside here, somewhere here. So it is again dividing into m1 from A point m1, from B point m2. And the same coordinates A and B are having the same coordinates x1, y1, z1, x2, y2, z2. Then the coordinates of M will be equal to m1 x2 minus m2 x1 upon m1 plus m2. Y coordinate will be equal to m1 y2 minus m2 y1 upon m1 minus m2, and the z coordinate will be equal to m1 z2 minus m2 z1 upon m1 minus m2. Midpoint, you know that if it is a midpoint, then midpoint x1 plus x2 by 2, so midpoint formula will be equal to x1 plus x2 midpoint from point, suppose midpoint is m, so its coordinate will be equal to x1 plus x2 by 2, y1 plus y2 by 2, and z1 plus z2 by 2. Midpoint formula. Centroid of a triangle. Fourth formula is centroid of a triangle. Centroid formula is yes. M1 minus M2. Yes, Sharik, denominator will be M1 minus M2. M1 will be bigger because you can see in this formula you are asking M1 or M2 because this distance is M1 more. So M1 minus M2, bigger one minus a smaller one. Yes. M1 minus M2. If the distance will be changed, then you can interchange M1, M2. So centroid of a triangle formula for centroid of a triangle is, suppose it denotes this is a triangle and its centroid we have to find its 3 points are given us A, B, C, whose coordinates are given x1, y1, Z1, X2, Y2, Z2, and X3, Y3, Z3. Then centroid O, you can denote by O here. So centroid O will have the coordinates x1 plus x2 plus x3, because centroid is the point where the median meets. This is the median. This is also the median. The median divides 2:1. So this is O point. Third median also will come from this point. So the centroid coordinates of centroid will be x1 plus x2 plus x3 upon 3, y1 plus y2 plus y1 plus y2 plus y3 upon 3, c1 plus c2 plus z3 by 3. This will be the coordinates of the centroid. This is the centroid of a triangle. Then we can also have, because it's 3D, so we will have tetrahedron shape also. So if we have to find the centroid of the tetrahedron, centroid of tetrahedron, centroid of tetrahedron. Tetrahedron shape you must have seen in chemistry. It is just I'll try to show you that shape is just like this one, diamond shape, you can say. It is like this, and there is a carbon here also this side. So you can take the other point, this one. Okay, so this one, it is just like this one, tetrahedron shape. In tetrahedron shape, if you want to find the centroid, you will have 4 coordinates, A, B, C, D. So that's why its centroid will be equal to x1 plus x2 plus x3 plus x4 upon 4, y1 plus y2 plus y3 plus y4 upon 4, and z1 plus z2 plus z3 plus z4 by 4. This will be the coordinates of the centroid of tetrahedron shape. Then next thing that we have seen in vectors also, direction cosines of a line. Now we have to see the direction cosines of a line. Direction cosines of a line. Line means line in space, 3D. You know that we are doing 3D. So 3D, we have x, y, and z axis. So suppose this is y axis, this one is x, z axis, and this one is x axis. This is x axis, this is y axis, this is z axis, and in a space there is a line OA somewhere. OA. This is the line OA. So it will make, with x-axis in the positive direction, this is the angle with the x-axis. X-axis sorry, up to here, this line. So this is alpha. From y-axis is making beta angle, and from z-axis it is making gamma angle, as we have seen before also. So direction cosines of line, directed line OA, BCs of directed line is having direction, so it is called directed line OA will be cos of the angle which the line makes with x, y and z axis. So cos alpha, cos beta and cos gamma, and they are denoted by L, M or N. So we can say also that is L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. But this is the direction from O to A. If the direction will be reversed, then what will happen? If the direction is reversed, then their angle will be reversed, pi minus alpha. Then if the direction of so it depends on the direction. So if the direction of this directed line is OA, directed line is reversed, that means if it will become AO direction, then the angles will be equal to, angle will become, so L will become cos pi 180 minus alpha. Angle will be changed in this case because we have to take the angle in the positive direction of, means anti-clockwise. So this is what alpha, then this will be, total angle is 180 degree, so 180 degree minus alpha. 180 minus alpha, you can see this is 180. If you go to this direction, suppose this is y direction, y, we can understand by y dash. So this angle, what will be, if this is coming this side, then this angle will be pi, because till here it is pi, so pi minus beta. The direction, this will become same direction, but this is pi minus beta. This angle will be pi minus beta. This is beta, then rest of the angle will be pi minus beta. Okay, understood? So therefore M will be equal to cos pi minus beta, and N will be equal to cos pi minus alpha, and cos 180 minus theta minus cos theta. So therefore it will become minus L, negative value. So therefore DCs will be now minus L, minus M and minus N. So when the direction is reversed, their sign will be changed. Just change the sign, then find the direction cosines of a line which makes equal angles with the coordinate axis. Next question. There is a question before that, direction cosines of a line passing through 2 points. We can see the direction cosines of a line DCs of a, we use small d for DC, not the capital one. DCs of a line passing through 2 points. How will you find? Passing through 2 points. Okay. Species of a line passing through 2 points. A, suppose this is passing through a point A1 whose coordinates are x1, y1, z1, and another point is x2, y2, and z2. Find the DCs. So DCs will be given, DCs of the line AB will be equal to it can be calculated by the difference of their coordinates divided by length of the line AB. AB is the distance between the 2 points, that is length of this line segment. And y2 minus y1 upon AB and z2 minus z1 upon AB. That means L, M and N are this one. We can say that is L will be equal to direction cosine L x2 minus x1 upon AB, and M will be equal to y2 minus y1 upon AB, and the third DC will be equal to z2 minus z1 upon AB, and where AB is the distance between the 2 points. AB, first we have to find the AB by using the formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Just find the distance and you can put in the above formula. You can get the DCs of a line. Then what about the TRs of a line? Direction ratios of a line. So DRs of a line. DRs of a line. Now, what are DR? DRs are the numbers which are proportional to the direction cosine. So any three numbers A, B, C proportional to any three numbers proportional to L, M and N. Proportional to L, M and N respectively are called DRs. Proportional numbers are called DRs of the line. So DRs are proportional to DCs. DRs of that line, of the line which is going to be considered. Now, so suppose we can have the proportionality, means we can say that A is proportional to L and any number B is proportional to M and C is proportional to N. Okay. Or we can say that now we can write proportionality as their ratios. So L proportionality will be removed, then we can put the constant. So L upon A will be, we can put K, A, K this side or that side, it doesn't matter, because we have to put BK is equal to M and CK is equal to N. So in this case, we get L upon A is equal to K. Similarly, M upon B is equal to K, or N upon C is equal to constant. So they are all equal to same constant. So we can write L is equal to AK, that we have already seen. Therefore, L is equal to, L can be written as AK, M is equal to BK, and N is equal to CK. And we know that what is the relation between L and M, LM and N, direction cosines. Their sum of the squares is always, sum of their squares is always equal to 1. So we can put the values here to check what is the relation between direction ratios and direction cosine. So how can we find that if the direction ratios are given, how to find the direction cosine? So here we can put the values. L, value of L is K A, so K square A square plus K square B square plus K square C square is equal to 1. So K square is common. We can write 1 upon A square plus B square plus C square, and then K is equal to plus minus 1 by A square plus B square plus C square. This is the value of K. Now, if you will put the value of K in this equation number 1, we can say this is equation number 1. So we get yes, square will come, then yes, square root will come. So substitute these values in ABC. So we get the relation between direction ratios and direction cosine. Therefore, L will be equal to plus minus A upon under root A square plus B square plus C square. So if you know direction ratios, you can find the direction cosine by using this formula. M is equal to plus minus B upon under root A square plus B square plus C square, and N will be equal to plus minus C upon under root A square plus B square plus C square. Therefore, direction cosines are this. ABC are direction ratios, and these are the direction cosines. Therefore, thus ABC are here direction ratios, DRs. If ABC are DRs here, as we have seen, then DCs are plus minus a upon under root a square plus b square plus c square, or plus minus b upon under root a square plus b square plus c square, or and z coordinate, z means n third direction cosine will be plus minus c upon under root a square plus b square plus